we're joined today by Roy Perez. He's an application engineer at Voltera,
Mhm.
and he's going to talk to us about a device they have that prints circuit boards. Katerina
Awesome.
Illich,
Hi,
I think you're a
everybody.
plant, aren't you? Yeah.
Yeah, my name's Katerina. I'm with Roy. I'm just one of the engineers here at Volterra. I'm one of the original co-founders of the company. I always like joining in on these groups all the time, especially from this area. Teresa, I'm really well familiar with the folks at Circuit Launch. I've been there a few times now. Lots of cool stuff going on over there. And I was probably at that maker fair about 4 or 5 years ago right now, so I apologize if I didn't recognize you back then, but it's possible we've spoken in the past. So thanks everybody for joining in. We're kind of excited to tell you all about our tech.
Yeah.
Right. I'm going to turn it over at this point to Roy.
Awesome. Thanks, guys. That was awesome. Thanks for all the introductions and giving me a little bit more information about your backgrounds and what you guys are looking for with PCB development, that sort of thing. But yeah, like Sean mentioned, I'm one of the application specialists here. I have a background in electrical engineering, and I'm just here to teach you guys and talk more about the Volterra V1. So the Volterra V1 is a PCB printer, like you guys already know, and it's mainly used in product development, research, education, to ideally shorten the development cycle for your R&D group or for your own personal projects, for any clients that you have. We kind of understand, and the reason why it came to be was to help shorten that development cycle for product developers like yourselves. Um, so what the whole idea behind it, typically, you guys know this probably more than myself, but typically what the design cycle looks like is you go from an idea and you potentially bring it out to a PCB factory or a fabricator to get an MOQ of 10 or 15 pieces done, depending on the density of the board and the complexity of it. It could get pretty costly, in some cases, more so than not. You would then get that design back from the manufacturer and realize you have to make some changes and make some optimizations to your board. So you would then have to kind of go through that whole process again, from an idea to an iteration to the manufacturer and back on the drawing board. So the V1 isn't meant to replace PCB factories in any way. It's meant to get you there faster by shortening that cycle, like I mentioned, to design and print within a few hours and have a physical prototype in your hands in a few hours, as opposed to a week or a few days, right? Um, so how does the V1 work exactly? So it kind of goes like this. This is kind of a layout of the workflow. So first you have your design and your idea. You would then use the CAD design tool, KiCad, Eagle, Altium, that sort of thing, and you would export it to a Gerber file. Our V1 software then takes that Gerber file, and then you would then quickly calibrate where the substrate is in physical space. So you would align the board so that it can understand where to print and where to drill holes. You would then move on to drilling the holes and printing the actual circuit. And that's done through the addition of a conductive ink. You would then thermally cure the circuit, insert the rivets, apply the solder paste, add your components, and reflow, all with the V1. Then you would go out and test your board and see what works and what doesn't work. Ideally, you would then go to the mass manufacturer, but if there are some changes that need to be done, you would go back and make some changes in your design software and kind of go through that process again. So there are four main functions to the V1, like I mentioned. So the first one would be to drill your through holes and your vias. Second, you would add the conductive ink onto the substrate. You would then cure the ink, and thirdly, dispense your solder paste. And then you would assemble your components, place them onto the board, and reflow using the V1. It has an integrated heater within the print bed. So you can do it all with the one machine. And here is a quick walkthrough video of how the V1 works, and it dives into a little bit more of the details of the machine.
Hi everyone, I'm Kat, co-founder at Voltera, and today I'm going to be showing you how to make a double-sided circuit board with the V1. So step one is to upload your design files. You can use any software you're comfortable with, just upload them into Gerber format. You'll see the toolpath is already calculated when you upload your design. So next, clamp down the sacrificial layer and the board. I'm using an FR1 board because we're going to be drilling into it. So once that's secured, snap in the proximity probe. It will be used to generate an accurate map of the surface. So once that's done, go ahead, snap in the drill head and fire it up. Now the board has been mapped in XYZ space, so the drill knows exactly where to go. If you're going to be using different hole sizes, the software will prompt you to change the drill bit after the current hole size. All right, let's print some traces. So swap out the drill head for the ink dispenser, let it calibrate, and begin laying down conductive ink. If you find a mistake on the board, you could easily reprint it using selective printing. This is a great feature for design modification and rework. Okay, so now it's time to cure this board. Simply remove the sacrificial layer, flip the board, and rest it on the baking ledges of the clamps. Curing takes about 40 minutes, and you're going to want to let it cool down after, so I'm going to go grab a snack, and I'll be right back. Okay, so that looks good to me. Now I'm just going to flip the board back over so that we can print and cure the bottom side. Okay, so our traces are printed and cured onto both sides. Now I'm just going to go pop in some rivets and use the riveting tool to secure them into place. Okay, with that done, we can clamp the board back onto the printer and go ahead, snap in the solder paste dispenser so that we can get some solder onto these pads. And with that done, I'm just going to pop some components onto here and watch them reflow directly onto the heated bed. This board does have a few through-hole components, so I'm going to go solder them using the provided solder wire. I'm using plenty of flux, and my iron is set to 200 degrees Celsius because the traces are heat sensitive. Okay, so let's see if my punk console works. Okay, so this is an example of a very simple circuit. Thank you all so much for watching. We can't wait to see what you create with your V1.
Perfect. Awesome. So yeah, one of the, I know you guys mentioned you're in product development or you're consulting for a client, and one of the things that stands out to me in that case is solder paste dispensing and reflow. The V1 is primarily used, can be primarily used by yourselves to dispense solder paste without using the need for stencils. We have a few customers doing that for that reason alone. They have 2 or 3 of these machines where they are populating prefabricated PCBs and using the dispenser to add the paste and assemble really quickly with the V1. So that is something I think you guys should kind of consider and think about. What are your costs for assembling your boards? How much time does it take you to do that? And what does that process look like right now? So this is just showcasing the precision more so of the solder paste dispensing. You can dispense onto 0603, 0402, and 0201. Reliability wise, you can get down to a 0.65 millimeter pitch, pin to pin pitch with printing conductive traces, and a 0.5 millimeter pin to pin pitch when solder paste dispensing. But that being said, you can work outside both of those specs as long as you you have some practice with the machine. Every machine is different in terms of if you're using 3D printers and that sort of thing. So understanding the calibration and the actual mechanics of the V1, you'll be able to work outside that 0.65 and 0.5 millimeter spec. And this little video here is just showing the reflow process. Again, it has a 550 watt heater integrated into the print bed. You can go up to 240 degrees Celsius with it, and the software allows you to add any custom profiles that you see fit, depending on the substrate, for example, that you're printing on. If it's PET or Kapton, you can adjust it to kind of match the substrate you're using. And talking about PET Kapton, we've found that the V1 not only is used for traditional PCB printing, but also for kind of additive, flexible new opportunities out there. So people are printing on PET, Kapton, for example, for medical sensors. NASA particularly has a few of these machines printing on O2 sensors so that they can integrate them into their helmets. Nike, for example, has wearables within their shoes, and they're using the V1 to prototype those different applications. We've printed on textiles like denim that you see on the right there, some stretchable materials that does require a little bit of experimentation to match the substrate that you're printing and the ink that you're using. There is a little bit of experimentation and thought that needs to go into that, but because it's an additive process, it doesn't limit you to what substrate you can use for your devices. And these are just two other examples. So some conformal electronics, if you're printing on adhesive back substrates, you can print onto that substrate and form it onto a 3D printed object, for example. That picture on the right is a heater that we've made internally just to kind of showcase the possibilities. You can also print on plastics and thermoform them to certain shapes and sizes that you need to do for your R&D or for your research or for potentially for a client. So since 2013, we've been able to get the V1 in 65 countries and over dozens of industries. We have about 2,000 units out in the field today, and the industries range from aerospace to education, IoT, military, all sorts of things out there right now, and companies out there right now using the V1 to prototype quickly. Just to show a few of the institutions that we're in: MIT, UCLA, Stanford, those research groups within those universities are using the V1 heavily, as well as startups and enterprises. GM, Facebook, Apple, Microsoft, they have the machine and multiple machines within their R&D groups just to validate designs, validate a series of components, validate substrates, to ideally get to production faster. And that's it. Thank you guys so much. I'd love to have a chat with you either right now, or if you have a question after the presentation. I'll forward off my email as well in the chat and my LinkedIn profile. Let's connect, and I'd be happy to answer any questions.
Okay. So you've had a number of questions come in, Roy. Let me just queue up a couple for.
I am so sorry. Yes.
So I'm gonna just take them in the order that they got asked. So there was a question on RF traces and printing antennas. Do you have any customers that are doing that?
We do. We definitely do. Who those specific customers are, off the top of my head, I don't know, but we have had a study done particularly on RF applications and microwave frequencies. The V1 conductive ink itself is good up to 7 gigahertz with no losses. Between 7 and 16 gigahertz, you're seeing about a 10% insertion loss when you get into the higher frequency range. So yeah, because it's an additive process and not, for example, an inkjet machine, the content of the ink itself allows the applications to be much wider. The reason for that being inkjet typically has a more aqueous material that you're dispensing, so about 30 to 40% metal content, whereas our conductive ink is about 80 to 90% content. So that's why, in terms of frequency or RF applications, you're able to get up to those higher frequencies.
Okay. And then if you mentioned it, I didn't catch it, but there was a question, then a couple questions on how many layers can you print? Is 2 the maximum?
That's right. Yeah. So right now, 2 is the maximum number of layers you can print using the V1. What a lot of customers have done to get around that is essentially it's mainly used for validating a design, right? So they would end up printing multiple double-sided boards and sandwiching them or connecting them together to validate a multi-layer circuit.
We've seen that particularly done, especially with the flex circuits, taking a film of polyimide or PET, or even a thin film of FR4, and then printing on the top and bottom sides, and then doing a lamination process similar to what would be seen in the industry. Unfortunately, there isn't an elegant way for the machine to actually currently stack those layers together. And hopefully up the product roadmap, maybe we'll have a machine that will be able to do that. But as of right now, one off PCB is dual-sided.
Okay. A question on the repair of gold fingers on an edge connector. Do you have anybody using this to do repair work?
Repair work is a little tricky, just because typically there are components already on the PCB that you're looking to repair. The V1 does have a selective print feature. However, there is an off chance that the nozzle or the actual dispenser itself could run into a already placed component. So repair work does get a little tricky with the V1. If it's a fairly clear board, or the SMD components are kind of off to one side, or any through-hole components are off to one side, that is more doable. But yeah, it gets a little tricky when it comes to repair work.
Yeah, I would add on that. I have seen customers using it for some interesting stuff like that. So you can take a pre-existing board, for example, mount it onto the platform, and all you need is 2 pads, typically one in the lowermost left corner and one in the uppermost right corner, to recognize as fiducials, essentially. So the proximity probe will actually find those 2 fiducials, and then of course interpolate and find the remaining existing features on the existing PCB. And through that mount, people have gone about and done repair work. The printer does have keep out zones for boards that already have components. But as Roy had already mentioned, where the struggle comes in is if there's very bulky components already sitting on the PCB. So if they're too tall, you have about an inch clearance between the board and the maximum height that the nozzle is moving. So you just got to be sure that you don't have anything that's too bulky and risks the nozzle potentially kind of crashing into that large component as it's kind of moving over the surface in XYZ space.
What's the cost of the device?
Yeah, so right now the V1 costs $4,200 US. That comes with the printer and the drill attachment, as well as a starter bundle to get you printing circuits right away. So your conductive ink, your substrates, your solder paste, everything you need to start printing. If you don't necessarily need to make double-sided prototypes or double-sided boards, you do have the option to get the printer without the drill attachment, and that would cost about $3,500 US.
And this is not very expensive, really.
Yeah, and for what it does, especially with other machines out there in the market, we try to make it so that it's accessible to everybody. and it's not limited to the select few companies or anything like that. We really try to price it at a valuable point for clients. Yeah.
Can those things have a shared situation where you will have like a lab and be able to send your design and having I'm talking about something similar to Shapeways.
Oh, do we currently have these in a lab? Is that right, JP?
Not necessarily yourself, but maybe a person that will have bought your device and will provide the service as an open situation.
Yeah, I believe Circuit Labs, I think Teresa mentioned, has the V1 in their particular makerspace, but definitely if we do have multiple makerspaces and fab labs globally that have the V1 in-house, that allow students or consultants or engineers come in and use the machine to create their PCB. Definitely we definitely have that.
Do you have a list of those people that provide this service, or is this easily found somewhere?
I don't have one right off the top of my head or anything, but I could forward you off some more information, Jean-Pierre.
Okay.
If anything, these people would be publicly, noticed if you do a quick Google search for Voltera, makerspace near me kind of thing. I believe they should come up on a quick Google search.
All right, thanks.
Yeah. Frank has a question.
Yeah, actually, my question is similar to the one that was just asked. So I was curious if there's any incubators or maker labs. Do you know if Hacker Dojo in Santa Clara has one?
I'm not 100% sure, but I could double check for you, Frank.
It's okay. I can reach out to them too.
Okay.
I was just curious if you knew offhand, but yeah, I know they have some pretty sophisticated machines that are available for.
The last time I was there, they don't. Circuit Launch definitely does.
Circuit Lab?
Circuit
Launch?
Oh, Circuit Launch. Oh, okay. All right, thanks. That's really interesting, by the way. That's really cool.
Question on what size the rivets come in?
Yeah, so we provide two size rivets, a 0.4 inner diameter rivet and a 1 millimeter inner diameter rivet. The bigger being for any through-hole components, and the smaller one being to connect two sides vias.
Roy, is there a size limitation on the PCB?
Yes, that's a good question. So the max size would be about 4 by 5 inches. If you can somehow clamp the substrate that you're printing using another method, for example, adhesive back tape or anything like that, you can get the size up to 4 by 6, but that would be the maximum size board, is about a 4 by 6.
How about the number of components or pins or something like that?
Nope, there isn't any limitation on that part. That would be completely up to you, and up to your discretion on how you design your PCB.
Okay.
You may have mentioned it, but we got a question on the minimum line width.
Yeah, so some of the specs, so minimum trace width is about 0.2 millimeters, or about 200 microns. Same with the trace gap. Pin to pin pitch, you can get down to a 0.5 millimeter. And like I mentioned, that comes with some practice and some intuition with the calibration process. Once you kind of understand how the machine works, you can get down to a 0.5 millimeter pin to pin pitch. So those would be kind of the specs right now for the machine.
Assuming that you sandwich boards in order to get 4 layers, typically internal layers are for planes. So assuming that you sandwich the boards, how do you interconnect to the internal boards?
So any sort of ground planes and that sort of thing?
Yeah, well, mostly ground planes, but sometimes you need to run traces over there.
Yeah.
How do you connect to the internal boards, internal layers?
Yeah. So that's a good question. I guess it depends on the substrate that you're printing on, but with the V1, you do typically print on bare FR1, FR4, or PET or anything like that. The way we would connect them is simply through your PCB design. You would just connect the traces to them. We typically, for ground planes or any solid pours, we print those in hatch plane style through the design software for two reasons. One, to save and conserve your ink, and two, to save on printing time. It does take a much longer time to print a solid ground plane, for example, or it just helps you conserve time and ink if you were to able to print the hatch design. And we do have some circuit design guidelines that we recommend, and I can forward those off to you guys as well, just so you can take a look.
Can you also give some idea of cost of the consumable, like the ink and all this?
Yeah. So the ink cartridge you can get, so it's $99 US, and a solder paste cartridge is about $49 US. Per cartridge or per ink cartridge, you can get on average about 50 boards, and that's a mix of both simple and more dense PCB designs. With a solder paste cartridge, you're able to dispense onto about 11,0603 pads. That number will bump up if you're doing 0402 or 0201. So if you're heavily printing, 40, 50 boards a month, you could be looking at $100, $150 per month in consumables. But that usually spans out, 2 or 3 months. So maybe 100, 150 every 2 or 3 months, depending on how frequent you're prototyping.
Very good, thanks.
Mm-hmm.
Again, I think it's very affordable, the solution that you provide.
Thank you, yeah.
So we're going to make a copy of the video of this webinar available. Roy, I don't know if we're going to be able to get a copy of your slides, but we can also post those.
Yes, yes, I'll definitely send that.
Jan, I'm sorry, I think you came in too late to get introduced. Did we get all of your questions answered?
I think Jan's one of ours.
Oh, we'll need to send him or her to Overcoming Painful Shyness seminar or something. Okay.
Sean, can I ask a question?
Sure, please go ahead.
Yeah, I answered the question about the ground planes. So then I had another question. Have you done has there been any reliability work done on varying the temperature to see how sturdy these things are, how reliable they'd be over time? So in other words, they're mostly just to be used quickly and then abandoned. Is that correct?
Not necessarily. No, we although we don't have official, ambient, varying ambient temperature experiments or anything like that in humidity. We do have a lot of users putting these in 3D printed enclosures, for example, that are sitting out in kind of communication boxes in the sun. That's in the sun, 16 hours a day, for example. But I would say they're pretty robust. We do have people using the same circuit that they've printed, a couple years previously, and the ink itself is very robust in the sense that it doesn't crack or anything like that. It doesn't oxidize. The reason why we use a silver conductive ink is because of the oxidation issue with copper, and that's a question we get a lot too. Is why don't we use a copper ink? Well, copper tends to oxidize, and that ruins the traces. There is no masking or anything done with our particular material that we're using. So it is quite robust. Although I know our material science team is working on something like that. We do get that question a lot. What is the longevity of a board printed with the V1? And once I have that information, we'll probably be posting that off onto our website, or I could forward that off to you guys directly once we get that.
Could you give also some idea of the roadmap of your future development? What is in the plan for making this even more attractive?
Yeah, there are some things that we're thinking about. We get a lot of feedback on how we can optimize the machine for our current users. We don't have any you know, bigger long-term plans for product development in the sense of traditional PCB printing. A lot of our changes are coming through our software, and there are a lot of things that we could potentially do through software changes with the V1. For example, an idea that was kind of put out there was the idea of milling using the drill attachment, for example. A lot of people are kind of thinking about using a CNC machine versus an additive process, but something like a software change to accept any subtractive process is an option for us. So that is something we're thinking about. We can't give out too many details, of course, about any of our roadmap, product roadmap, but if anything, just follow us, and I can include you in the newsletter, and that way you can stay up to date as to how we're progressing our product.
Sure, I would be interested in your newsletter, but I will go to your website. Probably I can get this recorded, right?
Yes.
Roy, can you put your email address in the chat? We've had some more detailed questions from Chuck and from Larry that I think it's probably worth perfect.
Yeah, Sean, I had one other question.
Go ahead, Carl.
Yeah, so if I create a 4-layer board in Gerber's, can your software split them into 2 boards so that you could stack them? You see what I'm talking about? Do I have to do all that on my own?
You would have to do that in the design software that you're using, and then upload them separately, essentially. Yeah. Is how it works is you'll have to upload single layers into the software, and then kind of mesh them together by aligning the board. So for example, you would upload your first layer, print your first layer, cure it, and do everything you need that needs to be done to it. Flip it over, print your second layer, and then you would have to do that process again for the third and fourth.
Do you have any metrics for the trace resistance?
Yeah, so the conductive ink has a resistivity of 12 milliohms per square, and that's sheet resistance, and it's uniform throughout. So it's about an order of magnitude less conductive than copper.
There was a question from Amir. Amir, can you ask your question again? I'm interested in the answer.
Oh, I'm sorry, I missed that. Go ahead, please.
Yeah, maybe I misunderstood the 3D printing concept. I thought that you're actually doing the 3D printing of the board. So why do you call it 3D printing?
So it's an additive process. It's not necessarily, we can't necessarily print directly onto a 3D object. The way you can do it with the V1 is you would print on a substrate that you can bend and form into the 3D object. For example, the heater that I showed in the presentation. You would print on that flat surface, and it would have to be an adhesive back surface. That way you can form it onto the 3D printed object that you're using. If that makes sense, yeah.
I think it's 3D in the sense that it's positive, not necessarily that it's they're building up a 3D object, if that helps.
Right. So it's really your machine is a epoxy adhesive dispensing machine that prints in X and Y, and that's pretty much it. And really, the advantage you have is quick to market, quick to test, that sort of thing.
Exactly.
Okay.
Exactly.
Thank you.
Well, if there are no final questions, I think I'm going to thank Roy for a fantastic presentation that triggered a lot of interest. Go ahead.
It is indeed a fantastic presentation. Very interesting.
Yeah. Thanks, guys. Yeah, and feel free to shoot an email to me. Yeah, sorry,
go ahead, Chuck.
Yeah, there's 2 questions I think might be of general interest. First off, on the drilling attachment, are you using standard off-the-shelf carbide printed circuit board drills where we could possibly change hole sizes by changing a standard drill without having to have you custom grind it?
Yes, yes. So,
Okay.
so it does come with a drill bit set. Yes.
Excellent. What is your material on your rivets?
It would be copper rivets.
Okay, so we could use by changing to a different drill size, we could accommodate, for example, a transistor heat sink hole by just using a larger drill.
Correct.
Okay.
Yeah. Yeah.
Can
The drill
we
itself.
edit?
Sorry. Go ahead. Go ahead.
Go ahead. Can we edit the tool path? Some of us have programmed CNCs, which would mean we could manually go in and correct to cause it to avoid a tall capacitor doing a repair on an existing board. And that's the last of my questions. Thank you very much, Sean, for accommodating.
Yeah, yeah. So you can change the tool path in the Z direction so that it won't run into any components. If you have something already kind of in the middle of the board, for example, you can do that.
Chuck, I was thinking the same. Okay, so thanks for asking that question. I think there could be something done for repair as well.
One more about the 4-layer issues. How do you have any recommended way of separating the two? Let's say that you make two layers. So do you have any recommended way? I suppose the rivets are kind of, bumping. They have some bumps. So any recommended way of separating the two layers?
So what I've seen in the past is kind of like, how they shield Arduinos together. That's one way I've seen the layering done, where they have a block a terminal block that you can connect with the pins to of a second PCB. So I've seen them sandwiched that way. I've also seen them connected via a flexible ribbon. If that answers your question. I'm not sure if that answers your question, Jose.
He's thinking about a vertical stacking, I think, not connecting them.
I don't know of a good way to do that right now, but I could double check for you, Jose. I'll get back to the team and see what their thoughts are on that. I'm sure they've probably put a little bit more thought to it. So let me get back to you on that, Jose.
Okay, thank you.
The truth is, it's tricky. It is a tricky process, Jose. As of right now, the machine, it does not do it in an elegant way. Anything that I've seen people do is a bit of a hacky solution that I wouldn't necessarily recommend to anyone.
The problem is that, 2 layers is very, very limiting.
Yeah.
So even the next jump, which is 4 layers, will open up a lot of possibilities. And essentially for the typical product that I design, 2 layers is almost unusable. It's only for very, very small projects. It's more for a maker, for a hobbyist. But for anything professional, 4 layers, I think, is the minimum. So I really suggest you to work a lot on that area, because it opens up a much bigger market.
Yep, agreed. It's something we're working towards.
There seems to be one obvious workaround. That's if the rivets on the mating boards happen to line up. You put solder paste on the damn rivets and you're done.
I've seen that done before as well, Chuck.
Yeah. So you can make it complicated. I mean, if you can't tolerate the offset caused by an array of pins, as was suggested earlier, I believe, by Roy, fine. Reflow the rivets.
Yep. Thank
you.
And on that happy note, we're going to break here. Thank everyone for coming.
Thanks, guys.
And we'll post this. And Roy's there's a lot of questions. Roy's put his email in the chat. It's roy@voltera.io. So I'll leave it at that.
Awesome.
Yeah, this is very nice. Thank you.
Yeah, thanks, guys. Thanks for joining me. I appreciate it. Yeah, shoot me an email or give me a call. Follow me on LinkedIn and connect with me on LinkedIn.
All right.